Hello everybody and welcome to this tutorial in which I'm going to show you how we can build this IKEA kids table in Fusion 360 using direct modeling. We will go into also how to prepare a design as a rough prototype, so that, for example, when such a CAD file is created, this could be given to an engineer to create a physical prototype. This is not a manufacturing model, but it is good enough to, for example, give someone an idea how you as a designer envision this to be constructed. And then we will also finish everything with a quick and nice looking rendering directly inside Fusion 360's own render engine. And with all that said, let's go ahead. So I will create a new design. Right click, we turn off the design history, we set this to inches, and there we are. So what's actually the best way to start? Let me go back to this piece. Again, if I look to the front, you see everything is nice and symmetrical. From this view, you see there I can see the tabletop, height position, the stuff below, the legs. But the legs are actually triangular. This frame, well, I can see best from here. So each of these components we create actually from different views. So check this out how I structure my approach. I will actually start with the tabletop. I go to the front view, make a sketch on this yellow plane, create center rectangle, 2-point rectangle, doesn't matter, 2-point is perfect here. There we are. Then I quickly add a dimension, 0.75 for the material thickness and 48 for the table length. Move this up a little bit, there we are, and escape. Now I would like to position this. Sure, how do I do this precisely, cleanly, because it's a symmetrical object? There are two ways actually. From the sketch origin, I can draw a line onto the midpoint and escape, click the line. Now I can turn this into a vertical line and then select the line, make this a construction line. There's one way. And then this line I can dimension. Method 2 is I can also create a point directly on this midpoint, because then I can use the horizontal vertical constraint to pull this over. And now this I can move up and down, but not left and right anymore. See, easy peasy. Let's go ahead, add a dimension from here to here. That is currently 22.25. This actually should be 24 inches, but that is 24 inches to the top of the table height. I know we have 3/4 of an inch material thickness, so 0.75. We just write an equation, 24 inches minus 0.75 material thickness, enter. There, 23.25. Logically, that's so simple math. I could have done this also by myself in my head. I just wanted to show you how you can create small mathematical calculations in there. When I add a new dimension, top to bottom, it tells you this is over constraint. It creates a driven dimension, which is actually good, because now this verifies that this is really truly 24 inches. Perfect, cool. When I click finish, now we have this sketch. I can go to extrude, drag this one out, 24 inches, but this actually should be symmetrical. It should only be 24, not 48. Now I could put in 12 inches, but look at this measurement. Whole length should be 24. That is perfect. Okay, very good. There we are. So the tabletop is actually done. I will dissolve this, and the sketch I can hide. The next logical thing to do is the frame that's below. I will create a sketch, and I look from the bottom and I select just the bottom face of this body. This will then create a drawing directly under the tabletop surface. Here I will use the center rectangle. I will hide my body so it's kind of gone. Can go to bottom view and then drag a rectangle out from the center of my sketch. So it's nice and symmetrical when I move this. Now let's add some dimensions. This one is actually 8 and this is 45. Perfect. Now I need something that helps me to create the long pipes and these shorter, wider pipes. For this, very easy, just some lines. You see how I draw the lines nice and horizontal using the grid. I don't rotate them. I get instantly the perpendicular constraints. There's actually, and there too, a sketch issue. These points weren't really glued onto the line. That's actually this coincident constraint. So you can just snap the point directly on it, or how I did it here, you just drag it back onto it. Very good. Let's add some dimensions. So U and U. 3 inches. And same here. Then this is 0.75 and 0.75. Now this drawing looks a little bit crazy. So let's make this nicer to read. You see how I put the bigger dimensions to the outside, smaller to the inside. The engineers will like me for this. If I don't do this, they will laugh at me. There we are. Now this looks also cleaner. Perfect. Good. That's all we need. Very limited amount of sketching. We can then select opposite pairs to extrude this one down to a length of 1.25 inches. And then I do the same also here and there, 1.25. There we are. Why is this actually shorter? 1 second. I undo. Looks like I 1.25 there. Must have had actually a typo. 1.25. You see how this is being fused together because the join operation is join. I say new body. Pay attention to this. Okay, good. So this is actually kind of good now. Let's give these parts actually some names. Table top. Then I will make a new group and say frame. And these I put into that frame. You see how I'm sorting up everything. Now, the legs here are perfectly centered on this plane. You see this now? How do we get them to there? We don't really have there a sketch, because if I turn on the origin, you see where the origin are. There, there, there. So how do we do this? I need to get one of these construction planes kind of like right centered under there. And that's actually very easy. Look, I can go to construct, then I will go to plane through two edges. Nope, that's wrong. Mid plane. That's correct. Looks like left and right. There and there. And there is a yellow construction plane. Perfect. Okay. What can I do with this yellow construction plane? Well, I can put a sketch on that. So this one I hide and this one I hide. So you just see where that stuff is. Okay. The next step is I can sample from this geometry actually where, for example, these two edges intersect with this plane or the sketch in general. We have this here, intersect. So this edge, click, this edge, click. You see, then we have these magenta dots. Here I turn frame off, I turn construction off. There you see this. This is actually very useful because now I have a height. What can I do with this now? I can, for example, draw first a line. I'm going to block out now my leg. I'm doing this a little bit fast. There, and I draw a line there, and okay. Then this line should be horizontal. This line is actually 8.5 inches. Very good. This point, I would like to be on the midpoint here, but the midpoint is there because this is one line, so this doesn't work. What can I do? Here, check this out. This line I remove. I will replace this with a line. This point, I will now vertically constrain onto there and then make this line horizontal. You see now this looks exactly like 50%, no? And then I can move this one over. This one is only a helper construction line. This one is a helper construction line. There. So now I do actually have kind of like the center ray of my table. So if I go back actually to the finished CAD model, you see there is a spherical body, two telescope cylinders, and then we have actually the feet at the bottom. Okay, so go ahead. We will create a circle right here. I press D for the dimension, and this is 2.6 inches. Okay, very good. This is much bigger than what we need. We later actually only need 1/4. Yeah, we'll see that. We'll come to there later. But this is kind of like the socket where now the first telescoping tube actually goes onto. So let's draw this tube. So we say from here to there and down. I just draw a line. I did this one on purpose a little bit crooked, so you can see how when making this all perpendicular, this line is now parallel to here. These two lines are parallel to each other and perpendicular to this. Perfect. Press D for the dimension. This will be 1.8 inches. That's the diameter. So the radius is divided by 2. And then I can coincident constraint this point onto the circle, so it perfectly intersects there. Press escape. And this actually has a length of roughly 20 inches. That moves it down quite a lot. Very good. Then actually we can go to the bottom. So I go ahead, start drawing a line down, going to here. There we are. So this is all perpendicular. These are then parallel. And I can also add and continue something to the inside. How much, for example, should this go up? Let's say this will be plus minus 6 inches. So there's plenty of material in this long leg for this telescope part to extend out. Now, the longer this is, the more we can lift actually the tabletop up. Again, this is just only a conceptual study, what we're doing here. We need to give this a dimension. That is 1.5 inches diameter divided by 2. So we have the radius. Beautiful. Good. Okay. Now this actually doesn't look too bad. Let's do a quick prototype. I press escape and I have here set this line to a construction line. I realized that's actually not smart. So I turn this off and I will add a line down here. This line should go straight down. You see, this is actually now this quarter part of the circle I need for the revolve command. So revolve, how does this work? I exit the sketch, go to revolve, select this pie section, axis, select this part and click done. There's now a 360 revolve. This piece I will hide for the moment. I will create a revolve of these two profiles all together. And the axis is this line. There we are. Very nice. Can also hide this. And then I will go ahead, select all this. This is the axis for the second part. There, pretty nice. These two, they're actually being welded together. So in our case here, we use the combine command and the join and join them together. Very good. To make this a little bit nicer, now later we can add a fillet. But for the moment, I leave this out because we're just planning on how everything is going to be put together. What could make sense is, at this point, let's actually take a look at how this would work when we mirror this along this plane. Okay, now they don't intersect each other. Very good. Yeah. I will undo this step because I only want to finish working this one leg, and then later I just mirror it 2 times to the left side and then to the back side. The next step what we have to do now is figuring out how can we put actually the foot in there. So I go to the left view, I go to sketch, zoom in a little bit, there's my line tool, then here I can draw a line down, a line up, and a line back, and a line down. Okay, very good. Yeah. We have a little bit of a tricky issue. You see how this is actually at an angle, and this is actually, yeah, doesn't go in there. So I will undo this a little bit. And we might have to think about this differently, how we're going to build this. Before I continue, let's actually take a look at how this piece is also built in real life. So here you can see a photo actually of this part. So it's a cylindrical disc that has kind of like a cone on top, and then there is just actually a very simple sphere socket. So the sphere socket is centered, and from the center of that sphere, the foot actually is going to be built from. So that was actually a really good insight. So let's go back to Fusion. Now back here in Fusion, I will go ahead with a circle. That's the easiest part to do first. So there we are. And kind of like 1 inch. That seems to be kind of like doable. Yeah, 1 inch, 0.8. That is too small, 0.9. 1 inch. Let's go with 1 inch. Very good. Okay. You also, what's very important is that the midpoint is above the bottom, because this actually keeps the socket in there. So I will actually try to see if I can constrain this a little bit. So here I have this point, there I have a point, then we add a dimension 0.25 of an inch. Very good. Maybe I move this dimension to here, this one I move to there, so it's a little bit easier to read. Now, because we have this kind of like designed, and you see here this can go, this moves up and down, so this is still loose, no big problem. The next step what we'll do now is we'll actually go ahead and now from this midpoint there we draw our line straight down. Then I actually simply draw this line to the right side. I have this other line here actually in my way, which is a little bit irritating and not really a big problem. I press escape. This line I delete. Oh look, now this point is freely to navigate. No issue, we just reconnect it. And then this we just reconnect. So very good. This also has to be vertical. Good. Okay. So the leg doesn't rotate anymore, and I can now simply draw in the rest that is necessary. So the disc at the bottom has a diameter of 2.3 inches, 2.3 divided by 2 for the radius. There we are. Oh, this flipped up actually a little bit. Okay, now we just, no issue, we just bring it down. All good. There we are. This here is, let's say 0.25, 0.22, yeah, 0.22, that's good. And then this height to here I can specify where this actually should be. 0.45. Very good. And actually now you see that this is still moving a little bit crazy. Why does this happen? And that's actually you see where this is rotating around. Now it's sliding actually on the circle. We can go ahead, select 2 lines, and then add an angle there in between. Let's say 105 degrees. Very good. Perfect. If I draw this line a little bit crooked, and then I can make these 2 lines parallel. So there I can see now where this piece would later be there. And here's another little prototyping tip. I draw these 2 crazy lines. Do a construction line, then this line to here I make parallel, and this line to here I make parallel, and then this line to this I make equal. There you can see now what I have. You can clearly see that here, construction line there. This one actually helps. This already gets a little bit complex. I always tend to try to keep sketches as minimal as possible, but this is actually totally sufficient for me to figure out the prototyping. There's not really a lot of space there, so I will pull this one down a little bit. That is actually too much. So maybe I delete this, bring this further to there. Okay, this actually looks good. Select these 2 lines. Oh, that's 104. Let's say 103. 104. Okay, very good. We can also lower this a little bit. You see that then increases, for example, the space. You see how by adjusting the values, we're also adjusting the sketch quite nicely. Perfect. Good. So with this done, we have actually this part, we have this part. Oh, we don't have that part. We could draw this line. I would like to try something first. So these two pieces selected, revolve along here. I will get a warning because this body folder is actually invisible. There we are. And I would like this to be a new body. Very good. Then I click OK. Everything is a little bit overlapping. And there is my foot part. This cone surface I select and press delete. And does it fill it? Yes, it does. Perfect. So that's good. So this actually allows me now, if I want to, I can go combine and say U minus this one, and please keep my glider. There we are. There we are. Very good. This actually should also be a tube. And I need something that goes in there. So poof, how do we do this? Here, check this out. I select this bottom face, then I go construction plane. I create an offset, let's say 0.25 of an inch, negative. I also see here a warning because I have the construction plane folder hidden. Now there we can see this. So this is a 1/4 inch. This is good. Why did I actually do this? Because I can now go ahead and say split this body with this plane. Thank you. So now I have this part, which I can hide. And I can hide this. I can turn this off. Then I can select this and delete it. And this should be a tube. I select both. 0.125 of an inch. There. Now there's, for example, the tube shelled out. There's my glide, and there's a piece that kind of like will help actually the thing to sit in there. Let's say we would like to press this, however, into here. How can we do this? Look at this. I select the surface, move this a little bit further up. Let's say 0.5 of an inch. Then I show this pipe again and say, from this, I would like this pipe to be removed, but keep the tool. There, now we have this nice poke, kind of like a shoulder socket with that piece inside. Yeah, you see, very simplistic geometrical work. It's kind of like you're in the wood shop. We make things out of raw material. We build the basic proportions, and then we go ahead and we are cutting and splitting and sanding, add all the details. Very good. So the last thing to refine is actually to take a look at what we can do with the frame we have. Before, let's actually select all this and make a new group. There we are. So I can hide this, hide the other stuff. And we would like to tell the prototyping shop that this should be square stock. So we have to actually round these outer edges first. Oh, we don't have to. It just looks nicer. And also in the rendering. And we buy this basically rounded. So using a fillet of 0.125 of an inch is good. So that is perfect. And then, because I rounded the outside, I can then select these caps, do a shell, 0.125. Very good. So that's nice and sturdy. Probably in real life also thinner, but in these demonstrations, it's easier to see these thicknesses. So now I can think about So that makes sense. I can drill holes through the bottom, connect this to the tabletop. I can drill holes through here, but how do I connect then this? And there are various ways how to do that. So this one I hide and this one I hide. Here I will go ahead and actually do another rounding, 1.25, same volume. There we are, so it's nice and consistent. And then I will simply core all those faces away with the shell command. There you are. You see that? And then when we take a look at this and this, there, very good. So no sharp edges anywhere, but yeah, this thing would simply fall down. There's nothing here that protects it. And this is actually a great feature of direct modeling, how you are thinking through the design and then how it can also be constructed. Before we continue, I would like to show you actually some of the product photos. So here we are. You see the shot from the bottom. There are the nicely rounded edges. There are some caps, the rounded edges. There are holes where these are actually drilled through, or basically a screw from the top goes down. And pay attention to this interesting banding here. So why is this so deformed? Because actually these ends were folded up, and then here was a flange that was folded up too. So when we then go to the side, we actually screw these longer pieces onto the pieces in the center. It's a very simplistic construction. And here, these are actually caps to hide the openings because there are screws inside and they are connected to the tabletop. In the tabletop, they also drilled holes in and then put a threading in. So the screws which go through are then going into the inserted threading channels which are inside the tabletops. It's a very good way to learn how furniture, or actually in general, how objects are constructed by simply studying really all the details and, if possible, taking everything apart. So for example, here we can see there's a weld line, not so good weld line. So they made some sort of half dome, then cut it open, put the tube onto, and then they welded it. Okay, very good. Let's go back to Fusion. So here back in Fusion, we know that we need there something to move up. So how do we do this? That's actually pretty easy. I will select this one and this one. I need a height reference. So these two faces I will extrude up, but to the height of this top face. But please as a new body. Thank you. Why did I do this? Well, because I can simply select all those faces. Yep, all selected. Then I do a shelling 1.125. And look at that. I have actually my left and right metal brackets. Okay, very good. So inside there would be the kind of like the nut for the screw, and through openings which we could cut here, we would be able to screw these two pieces together. And technically speaking, these pieces are folded up. So for something like this, you can use the sheet metal to do it. Then it's a different approach. But for the basic prototyping, this basically very clearly indicates that here we have the folded parts and then flanges which are still in there too. And these four, I can all move into that frame. And there we are. So not 100% accurate, but good enough to give the engineer actually an idea of how this should be designed. Very good. So one thing left, there's actually an opening here. This is also a nice example of how we can do direct modeling. Really nice and fast. So I just would like to create a cap, something that sits on top. So I will extrude this face 0.25 of an inch, but as a new body. Very good. But then, yeah, I still have that hole. How do I get rid of that hole? Well, that's easy. We just simply select these internal faces and click delete. Done. Super. We need to make some copies. So let's, I will go to this one, make a copy from there to there. Beautiful. Okay. And since it's really the same, so these two bodies, again, copy from this corner, and you see that was the outside, to there's the midpoint there. Very good. There's nothing inside yet, and that's not really developed. That's all good. Perfect. In a similar way how I built actually the socket to hold the sphere, I could also select the inside of this piece, extrude it, and then use this body to cut the groove from the outside. Because this video is a little bit longer, I will skip this part. Because I showed this to you. You should be able to do this on your own. And this is not the last video. So a little bit of a rounding, 0.125 divided by 2. There we are. Okay, that looks nice. Here we can now add actually a little bit of a rounding too. 0.5. Technically speaking, that's a welding. Here, make this 0.125 divided by 2. There we are. Actually, we can do the same here. 0.125 divided by 2. And this edge, I will simply select just a little one there. Whoop. I said just a little one. 0.05. Very good. And then this one here, maybe a little bit, not too much, 0.03. The size is just really a matter of preference. 0.03 there. Beautiful. Very good. Very good. So all these features I can actually dissolve. So they're all done. And the tabletop needs to be rounded. So I will actually select all the edges of this tabletop at the same time. And you will see what will happen when we select all and then do a nice fillet, 0.125. And divide it by 2. That is actually very good. So when I zoom in now, you can see how we have this really nice triangular fillets and then all the others join onto it. Very good. The legs are left. We simply create them with a pattern. We just mirror them over, bodies. So you just have to select them all and there. Go over. and then one more time, mirror, 1, 1, 1, 1, 1, there, there, and over there. Very good. Perfect. Okay. So I would say that, for example, at this point, the modeling is kind of like done. We can add more details to it. For example, to help more the prototyping, adding more details can also elevate, for example, the realism if we want to really show how, for example, the screws and the connection is done. We would have to model this, cut the holes, etc. So I could create a sketch on here and then basically project a plane. So I'm just only quickly showing you this. You don't have to do this, but just so you can have an idea of this might be kind of like the last step. So on here, I create a sketch and then I can project. Look at this. I project this into that sketch. Now you see I have now actually kind of like a perfect border. And then here there's a midpoint, draw a line, and then there is kind of like a circle there and there. Let's say these two circles we make equal, and then 0.5 of an inch. How do we do the dimensioning? Oh, very easy. Hey, midpoint to this point, to this point, midpoint. These lines are all horizontally, they're already perpendicular. Very good. Cool. Then I can just make them all equal there. And U to U equal. Perfect. Yeah. And with that done, I can just go to extrude. Just need to take a look at this sketch there and cut through into the piece. There we are now. So logically, I then need to have holes there too. How do I do this? Let me show you something interesting, how we can do that. So I'm actually cutting this one completely through, actually not completely, but till there as a new body. So that's a little trick. And then these I make actually way smaller, 0.125 there. See that? No? Because it's very useful to simply say, so this one and divided, cut by U, keep the tool there, and then I just repeat U, zack, zack, and right click, repeat U, zack, zack, right click, repeat U, zack, zack. No, U, wait. Yeah, okay, very good. These two tubes here, I can, for example, move really far away and then make them wider, or because that's always then a source of making mistakes, I delete them and I go to the extrude command one more time. For example, push this out. Now you see now I have exactly the correct dimension. Select these two, bring this over there, there, and then I cut this one by U and U. Don't keep this stuff. Flop. There, look at that, no? So that basically, I think, explains how this is done. Because I used actually three-dimensional objects for the cutting in only one simple sketch, I can then mirror these objects over to the other side and then also do the cutting there. So I don't have to draw multiple sketches all the time. Very good. So for example, because it might show up in the rendering, this is basically now what I will do, just as kind of like a quick demonstration of what I just said. So I do this symmetrical, so that just barely cut in there, new body, thank you. And then I will go ahead and say mirror UU over the other side. Thank you. And one more mirror. Zack, zack, there. And to there. Very nice. Then I say U minus these two. Thank you. And U minus these two, but keep the tool, thank you, because I will actually, to make things a little bit easier, this time I move these two out. Then I will go to faces and select this face and this face, move this over. Then I select this face and this face and go to press pull minus 0.125. No, it doesn't work. Ah, okay, never mind. There we are. And well, as usual, same process. You actually notice that this is labor intensive. And that is the reason why I said to do these things only at the end when it's really necessary. Because if you make any mistakes and you have to fix these mistakes, it can be time-wise very costly. There we are. Beautiful. Okay, wonderful. That we can dissolve. The sketch we can hide. The construction plane we can show. These two I delete. And all this. So this is the leg. Okay, so we have a selection tool. There we are. Okay, so from that one to that one, that is the leg. What is this? Cap, 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 cap. These go into the frame. And there's actually this part we delete, this part we delete. Okay, very good. Perfect. Wonderful. So at this point, I would say we can call this done. It's perfect for presentation when we talk to the client or a prototyper that can really well understand what our intent is. And let's bring this to an end by creating a nice rendering. We can press A to create materials here, or we go directly to the render engine. There we are. Go to appearances, and we can start with the tabletop. So this should be kind of like whitish. So when we scroll through, we have various options here. I just go to paint, and we have glossy, various types. I have like the paint enamel. I will download this one, and then I can drag it onto that surface. Very good. When I go further down, we also have metal flakes and metallic. We have powder coated. So there are various different types. There's also plastic, for example. So we could go ahead and go to the metallic, and now if you take a look at this, it looks nice and diffuse, or the metal flake. this actually was kind of like a grayish part. So I will download this one and then actually add this onto the individual parts by simply dragging this onto everything here. There we are. And down here too, to be careful that you click the correct pieces, then also the metal elements. There we are. We can do a quick rendering actually to see how these materials look by simply going to this in canvas render and turn this on. Now we can see if we actually like this result. Maybe go to this view. Looks good. What about maybe we make this white? There we can see how we can, while we're rendering, we're kind of like playing actually with the kind of like the look and the feel of this product. Maybe white legs do actually feel a little bit better in this case. There we are. Beautiful. Okay, I will turn the rendering off because based on how strong your computer is, that runs faster or slower. This, for example, was more kind of like matte on top and then glossy at the bottom. So how I'm going to do this, I will actually, in this case, simply go by, I can go with the plastics, for example, but they can actually run slower because they are calculated correctly. I will simply go to paint and glossy. So I do have, for example, this dark gray. I will not use black on purpose because black and white can actually in renderings turn out very, very too dark. So most times I just work with a less, how could I say that, black material or white material. Very good. These, for example, are plastic pieces. So this might actually use there another material. To make this easier, I just download the blue, put the blue onto it. And I know that is actually not correct. You notice here sometimes Fusion has an issue with the interface. Sometimes we have to close actually the appearance. And then we can go back. Or go to the design and then we go back. Okay, thank you. There we are. And there we are. And there we are. Push this onto there and there. And then we can also pull the color from up here. And then we simply go in, double click and adjust the color. There. Cool. Okay, let's do a rendering. No, that's not too bad. There, noticed this is actually missing. Oh wait, that's this one. Wait, which one is it now? Is it this one? White. One second. Pressing A. So that is the enamel gray paint flakes. And paint white. Appearance. Actually, I forgot now which one is which one. Right click, select objects to be applied. Okay. That is that material. Good. So you go into there. Perfect. Figure it out. So then when we do this rendering, this is kind of like the preview rendering. It will take a little bit of time. And if you don't have that much time, you see down here how this is progressing. We can also use the cloud rendering. While this one is working, you can actually capture an image of this rendering right now. Or what you can do is you can go to render. Okay, I have to save this design first. So let's save this. IKEA kids table. There we are. Very good. And then when I go to render again, go to render. This is now the aspect. Cloud render or local render. Local render is just basically in the final rendering. It just cooks until it's done. Or we go to the cloud rendering, click render, and then actually, as you can see, it will create that image. And then once it's done, it's being downloaded, and you have it. Okay, that's it. We did it.